It's 3 in the morning. Your dog is asleep beside the bed, and suddenly her paws start twitching. First one, then both, in short, ragged jerks, as if she's running. A muffled sound escapes her throat, not a bark, something quieter, closer to a stifled whimper. You look at her and catch yourself thinking what you've thought 100 times. She's dreaming about something. You don't know how you know it, you just feel it. Everyone says it, it's obvious, and at the same time completely unprovable, because you can't get inside her head. You can't ask in the morning, "What did you dream about?" That's what everyone believed, until the year 2001. Because in 2001, 2 American scientists did something that sounds like a line from a science fiction novel. They read a dream. Not a human's, a rat's. They recorded the activity of its brain while it was awake, and then while it slept. And they watched the sleeping brain play back what had happened during the day. The same pattern, the same neurons, in the same order. And this is where you stop being charmed by the twitching paw and run straight into a question that genuinely unsettles you. If an animal's brain reproduces the day it lived through while it sleeps, does that mean the animal is living it again? Not just processing data the way a computer does at night, but living it from the inside, the same way you live your own dreams. That's the question for today. Hold it in your head until the end, because it's going to turn out far harder than it seems right now. First, what exactly happened in that lab? The Massachusetts Institute of Technology. The scientists, Kenway Louie and Matthew Wilson. The paper comes out in the journal Neuron in January of 2001. The title is dry enough to make you yawn. Temporally structured replay of hippocampal activity during rapid eye movement sleep. But behind that phrasing is this. Rats were trained to run along a circular track for a piece of food. Into the brain of each one, they implanted the thinnest electrodes in a region called the hippocampus. It's the part that handles memory and where you are in space. It has special cells called place cells. Remember that term. One cell fires when you're at one point on the route, another at the next, a third further along. As the rat runs the loop, the place cells light up in a strict sequence, like the bulbs of a string of lights chasing each other. The scientists recorded this melody of the run. For each rat, its own unrepeatable one. And then they waited for the rat to fall asleep and enter the phase of rapid eye movement sleep, the very phase in which humans see their most vivid dreams. And the string of lights lit up again. The same sequence, the same cells, in the same order. And here's the detail that makes your blood run cold. At the same speed. Not a fast forward, the same pace as in waking life. Minutes of experience lived again, second for second. The match was so precise that Wilson later said they could look at the sleeping brain and tell where on the track the rat was running in its dream. Whether it was standing at a turn or racing down a straightaway. Now the numbers. The scientists recorded 45 episodes of rapid eye movement sleep. In 20 of them, the pattern of the daytime run played back so clearly you could overlay it onto the real route. Almost half the dreams, literally, about work. In its sleep, The rat was running the maze again. And this is where an honest person has to stop, because the skeptic has a strong, inconvenient argument, and it's fair. The skeptic says, "Hold on, you've proven that neurons repeat the daytime pattern, fine. But that's not a dream, it's a technical procedure. The brain is rewriting fresh information from working memory into long-term storage, tidying up for the night, the way a server clears its cache. No experience is required for any of that. A hard drive doesn't remember files when it copies them, it just moves data around. And it's a strong objection. Neural reactivation, that's a fact. But the rat feels something. That's already our interpretation, stitched on top. Very tempting and unprovable by that experiment. So yes, the running string of lights on its own doesn't yet prove a dream in the sense that you have dreams. But science didn't stop there. And from here, the evidence climbs. Let's go up a step, from the pattern in the neurons to the body. Let's go back half a century, to France, Lyon, the 1960s. The neurophysiologist Michel Jouvet, one of the people who opened up rapid eye movement sleep to the world in the first place, asks a simple question. Why doesn't a sleeper move? Why doesn't the body carry out what's playing in the brain? He found the answer in a tiny part of the brain stem. During rapid eye movement sleep, this part does one thing. It switches off the muscles. Total paralysis. A natural safety catch. The brain rages while the body lies still, so you don't leap up and crash into a wall living out your dream. And here's what Jouvet did. In cats, he carefully damaged that exact safety catch. He left everything else untouched. The cats kept falling asleep as usual. But when the sleep phase came, they got up, with their eyes closed, asleep, and they began to hunt. They stalked invisible prey, pressed themselves to the floor, struck a paw at empty air, arched their backs and hissed at a threat that wasn't in the room. Some groomed themselves, tending invisible fur. They were acting out a dream, the whole thing, with behavior, with emotion, with a real hunt. The cat in its sleep was chasing a mouse that doesn't exist. Look at what we've got. In the rats, we saw the pattern inside the brain. In Jouvet's cats, we saw that pattern come out into the open, turn into complete behavior. The dream took on a body. And here's what matters. That same broken safety catch exists in people too. There's a condition in which the same brake switches off in a person at night, and the person starts to move in their sleep, to live the dream out with their body. Jouvet's discovery in cats helped us understand it. That mechanism that guarded your sleep last night, we first glimpsed it in a sleeping cat chasing a ghost. Now a step higher and stranger. Let's leave behind anything that even remotely resembles us. Let's go into the ocean. The octopus. It has no spine, none of our brain structure. Our last common relative with it lived more than 500 million years ago. It's a different branch of life, an alien mind in its purest form. And in 2021, a group of scientists publishes, in the scientific journal iScience, observations of octopuses of the species Octopus insularis. It turned out the octopus has two states of sleep that alternate with each other. Most of the time, it's in quiet sleep. The skin is even, pale, the pupils contracted, the body calm. The episodes are long. And then, briefly, for about 40 seconds, something else sets in. Active sleep. The octopus's skin suddenly erupts in patterns. Colors and textures run across it. The eyes move. The muscles twitch. And a minute later, it sinks back into the quiet phase. 40 seconds of storm and calm again. In its rhythm, it disturbingly resembles the alternation of sleep phases in us. Here I have to put on the brakes. This is not proof of dreams. It's a cautious hypothesis, and the authors themselves phrase it carefully. We don't know what's happening inside the octopus. Maybe those patterns are just the skin warming up, the pigment cells rebooting, with nothing behind them. But it's hard not to wonder. For a waking octopus, the color of its skin is its language. That's how it camouflages, threatens, communicates. And if a creature is replaying its day in its sleep, shouldn't it speak that day out in the only language it has, in the language of its skin? From the rat to the cat, from the cat to a creature that's essentially from another planet. And at every step, we see the same thing. The sleeping brain returns to what it lived through. The further from a human, the more astonishing it is that the pattern repeats. Let's go back to the rats from that lab, to that same paper, because it has a detail people usually don't linger on, and they should. The scientists could tell from the dream pattern not just where the rat was on the track in its dream, they saw the transitions too. They saw the sleeping rat reach the very spot where, during the day, food had been waiting for it. And the activity at that point changed, the same way it changed in waking life when the rat got its reward. Think about that. This isn't just a map of the route, spun through in the dark. It's a route that kept the spot where it felt good. The rat in its sleep ran all the way to the place where food had been during the day, to where its reward had waited. We're used to thinking of a rat as something almost mechanical, a gray little creature, a maze, a piece of food. But here is a small brain in total darkness, at night, returning to the track of its own will, running it again, all the way to the end, to the place where, during the day, it felt good. If you've ever had a dream in which you went back to a place where you'd felt good, you understand that rat better than you're willing to admit. And this is where we run into a wall, the very one where all of science falls silent. We've seen the reactivation. We saw the pattern of the day played back at night in the rat. We saw it come out into the body in the cat. We saw a hint of it in a creature from another branch of life. These aren't guesses. They're recordings, numbers, published work, direct evidence. But there's a border that no electrode crosses. Between the rat's neurons repeat the track, and the rat is dreaming. The track lies a chasm. On one side, a measurable fact. On the other, subjective experience. What it's like to be a rat and see your dream from the inside. Whether there's anyone in there for whom that dream exists. And the honest answer is, nobody knows. We have no instrument that measures what it's like. We can't climb inside another being's experience. We can't even prove 100% that the neighbor down the hall has dreams. We simply believe him because he's like us and can tell us. The rat won't tell us. The octopus even less. But look at what's happened over the course of this conversation. It used to be that "my dog is dreaming about something" was a sentimental phrase, the guess of a loving owner, the kind you can smile at condescendingly. Today we have recordings of a brain that at night runs back through its own day. And the question has shifted. It no longer sounds like "maybe they dream about something" or "maybe we're making it up." It sounds different and more serious. The experience is most likely there. We just don't yet know how to measure it. And no proof is not the same thing as the answer is no. The absence of an instrument is about us, not about the rat. We used to be alone in our dreams, the only ones on the planet who leave for another reality at night and come back. Now it looks like we're not. That the same door opens in the head of the dog beside your bed, in the head of a cat, maybe even down there in the dark on the floor of the ocean. And if that's so, then a dream stops being the thing that makes us special. It becomes the thing that connects us to every creature that has a brain and a night. It's 3 a.m. Your dog is asleep beside the bed. Her paws are twitching. Somewhere, right now, she's running. And now you know, those aren't empty words. Don't wake her. Let her finish watching. Sleep well. If breakdowns like this, about what's really going on inside the heads all around us, are your kind of thing, you know what to do with that subscribe button.